Hello guys, it's high voltage time again. This time I will show you a power supply, a second one. Last video I showed you the Pharmacia BioNTech EPS 3500 XL with only 100 watts but at 3500 volts. This time I have something more juicy, more powerful. It is a GIBCO, I don't know how to pronounce it, BRL PS9009, and it has significantly more power. It's a 3 kilovolt power supply that can deliver up to 250 milliamps and up to 250 watts. Again, that means that even if you're outputting 100 volts, you cannot exceed the 250 milliamps or the 250 watts. It's a rather nice power supply in a nice case, really nice case. It's quite large. It's probably from the 90s. It has a VFD display, a 2-line by 16, I think, I don't know. A 2-line VFD display, that's not very common to this kind of supplies. And a lot of buttons with an interesting layout. You have 2 rows of buttons. Above row is the functions, and the lower row with the black caps are the numeric input buttons. So let's try it. Activate it. It greets you. Just for information, all of these power supplies have a feature called load. They need a minimum load to start. That means that if you do not provide them with some kind of load that simulates the electrophoresis cell, they will not voltage in the output. Many of them it is possible to disable this feature in the menu. Some of them are hackable with hardware, and some of them I don't know how to be done or not. It's possible or not. This one has no feature in the software to disable it, and honestly I do not know how to do it in hardware, or I didn't try it, and to be honestly I'm not really interested in that. So it wants us to press the stop button. You have a program places, I think we have 99 programmable voltages and to can use. It is quite easy how to set the voltage, the current and the power. For the voltage you press volts, and let's say 220 volts, you have to put 0 2 2 0. Same with milliamperes and watts, and then you press the start stop button and it should output something. You see, it's already outputting 220 volts, and the lamp I'm using is a 25 watt lamp and draws 117 milliamps. I'm using this kind of test fixture. It's called Mega Man. I have it quite some years ago. It is modular, and you can daisy chain the different modules. For example, A14, E9, G9, 220 volts, etc. Here, it will be possible to daisy chain the other modules. It has a switch and a fuse. I like this fixture for small loads and for testing different bulbs. Okay, that was 220 volts at 117 milliamps. This thing is capable of 250 milliamps and a lot of more voltage. The thing is that with a higher voltage than 220 volt, there is some kind of load needed. And it's not very easy. I do not have any load, electronic load yet that goes up to 3000 volts. As I said, yet. Yeah. This is why you see this contraption. And no, these are not the Christmas lights of the upcoming Christmas. This is just a crude dummy load that I put together that can go up to 4000 volts. For the moment, what you see here is 3200 volts. Each row, each line of lamps is 1200 volts. So we can easily test this power supply with, and we can go up to, let's say, 190 milliamps. It is quite near its limit of the 250 milliamps. So let's start playing with high voltage. And the first thing would be it's very difficult for me to use the buttons and the camera in the same way. But anyway, let's use a higher voltage, PO2, and that's 1000 volts. This is how 1000 volts look. Merry Christmas. Anyway, we have 32 milliamps at 1000 volts and 32 watts. Next thing is let's go 1000 volts higher. Stop it. Again, program 0, 3. Then we have 2 kilovolts. Let's output 2 kilovolts. Ta-ta! And everything goes brighter already. And the current is already rising. We have 50 milliamps at 2000 volts. This is quite some juice at the moment. We are almost drawing or delivering 100 watts. In reality, 98 watts. And now let's go all the way up to 3000. Again, program 04, and we have 3 kilovolts, and look what happens now. Yeah, that thing is bright. 3 kilovolts. Here we have 3 kilovolts, and we are burning almost 190 watts at 63 milliamps. So this is quite a powerful high voltage power supply. This blinking on the display is just on my camera because it's synchronizing with the lights here. But anyway, for me this is the best. It not only looks good, but the best power supply, most powerful power supply, electrophoresis power supply I had till now. We just saw how it works, what it can do, and now we will see what it looks inside. And inside it is, for me, even more interesting, because this thing is the most hackable one of the electrophoresis power supplies I had till now, and you see soon why. By the way, if you like what I'm showing you, if you like my videos, please press the like button and subscribe. So let's see what's inside. So let's have a look inside. I already removed the screws. There are 4 screws. This thing is, even if probably not necessary, extremely service friendly. Take it apart. And let's see what we have inside. Let's start from the right side. A nice chunky mains filter, rectification, 2 fuses, auxiliary power supply, a linear auxiliary power supply, the main rectification here. Here we have one big chunky IGBT that goes up to, I think, 1400 volts to 25 amps. It's a Toshiba one. It looks like a flyback. It's pushing the limits to a flyback converter. It is a very old PWM chip, SG3524, 25, sorry. Feedback optocoupler, etc. A very nice high frequency. No, I don't think it is a, I don't know. I don't think it is a flyback. It seems to be a forward converter, a one switch forward converter, because here I see it has two primary windings. The one is the reset winding probably. It goes to these diodes. Again, chunky, very nice, at least 250 watts, at least. High frequency, high voltage transformer, ferrite transformer. And the good thing is, it has only one output winding. In the other power supply, in the Pharmacia I showed you, it was a quite complicated output design with stacked windings and two different rails, etc. This thing is keep it simple. You see here the string of high voltage diodes in series. You see here 10 capacitors, all of them in series with a bleeder resistors in between, and a string of resistors that made the resistor divider for the feedback. That means that this part is completely hackable. You can change the diodes and you can change the capacitors to have a much better filtering. Let's put this thing away here. So I like this very much. This power supply would be theoretically usable for other things too, that not only the electrophoresis, but powering other things too. But okay, let's continue. Yeah, we have some analog part here for the regulation and the whole digital part. It's a microcontroller, and unfortunately here, the infamous zero power amps that were very widely used in the 80s and 90s. These things die all the time now, and you have to replace them. But thankfully, this thing is socketed. That means you can put a FRAM instead of that. That doesn't need any batteries and nothing. They are replaceables for that. This is how it looks. Let's see, it's on the front. Yeah, you like my turnaround? Bing, bing. Anyway, a very impressive component count here for the VFD display. Wow. There's so much stuff here just for the VFD display, two-line VFD display. Below that, the buttons and the high voltage stuff. By the way, this is how it looks on the back. IEC connector, two fuses. It is only for 220, 240 volts, not switchable. The fan, a very nice fan. Not the most silent one, but it's a Pabst. It's a really good brand fan. So this is how it would look inside. As I said again, a beautiful case. Look at this case. The case alone costs some money. Yeah? It can be done a lot of stuff with that case. And for me, this is hackable. This part is hackable. The output part is hackable. You can use different capacitors, combination electrolytic and ceramics to power other things. The only bad thing on all these electrophoresis power supplies are the pre-programmed limits in here. That means that it can do only 250 milliamps, even if you put out 100, 100 volts, yeah, etc. Anyway, this is, if somebody could disassemble the code here and remove these limits, this thing would be great, to be honest. Yeah, just for information, here you have the primary bridge, filtering, X capacitors, Y capacitors, here MOVs and inverse current resistors while the capacitors are getting loaded, NTCs. Yeah. This is how it looks outside. It's nice, I really like it. And the case, it's the most nice case I have seen till now in such a kind of a power supply. Again, a bird's-eye view of all the insides. And a last overview of this thing working at full power, 3 kilovolts, almost 100 milliamps. And here you can see my complete arrangement of this crude resistive power dummy load I made just for testing this kind of power supplies. It's capable, if all of them are input in series, of more than, I don't know, 4,300, 4,500 volts, or 4.5 kilovolts. Yeah? But for that, it's enough to use 13 bulbs at 15 watts. This will be used in similar power supplies. For other power supplies, I have already made a high voltage load dummy supply, dummy load, sorry, that was a brain fart, sorry. But this one would not start because probably of the timing with my electronic load. So this is why I used this kind of load to can test this beautiful power supply too. Again guys, if you like my videos, please press the like button and subscribe. This would help me a lot to grow the channel. Again, thank you. Cheers.